Now we will complete an independent t-test. We're going to run an independent t-test on our sample data set. Here is the sample data for our math as usual versus Z-math groups. And let's first take a look at our variable view. If we look at values here for group, we can see what our values are. So those that are identified as 1, that are coded as 1 means that that individual was in a math as usual group. Participants who are identified as with a 2 is in the Z math group. Okay, so before we began our test, the only thing extra that we need to do is check for normality, because we already said that homogeneity is going to be tested when we run the actual SPSS test. So, very first thing I want to do, let's check for normality, and this goes back to earlier in the semester when we checked normality. That was back in module 4 when we tested for bias. So if you need to refer back to any of those resources, that would be in module 4. So let's click on Analyze Descriptive Statistics and Explore. And so our dependent variable is our group. Is score, and group will be in our factor list. And we are going to click on plots. We do not want box plots. We do not want a stem and leaf. I do want a histogram, and I do want normality plots with test. And this actually lets me select the Levene's test also here, but we're just going to go ahead and select normality plots with test and histogram and click OK. So this will allow me to compare using both a graph and statistical test. And so here is our test for normality using our Shapiro-Wilk. Notice that significance does indicate if these values are greater than 0.05, so they are not significant, which we don't want them to be. So this means that it is not significantly different from a normal curve. So that means that our data are normal for both groups. And we can also examine the histograms also. This is our histogram for math as usual group, roughly normal, and the same for our Z math group, roughly normal. Okay, so now let's go ahead and run our t-test. Let's go back to our data set. Here's our main screen. We're going to click on Analyze, Compare Means, and we're actually going to click on One-Way ANOVA. And on this One-Way ANOVA menu, I want you to move the continuous variable, which is score. We're going to move that to the dependent list, and we're going to move the variable that contains our categorical variable, which is group, into the factor window. So one note here is that SPSS does offer a t-test option, but the ANOVA option is actually easier to load, and it produces the exact same report. So we always want easy, efficient, fewest amount of steps, so we're going to go with One-Way ANOVA. And this also gives us our estimates for effect size as well. So I think that would be something interesting to click on as well. All right, so now we're going to click on Options button. And here is our One-Way ANOVA options menu. We're going to check descriptive so we can get our descriptive statistics. our homogeneity of variance, so we can check our assumption. We want a means plot, and then we will click continue. And this will take us back to our one-way ANOVA menu, and we will click on OK, and the t-test will process. All right, so here are our descriptives. It gives us our sample size in here, so both of our groups are at 30. So they're both at least 30. Here are our means. It shows that our math as usual group has a mean of 75.77. Our ZMath group has a higher mean of 80.97. Tells us our standard deviation, so on and so forth. All right, so let's continue completing our pretest checklist. So we still need answers regarding the homogeneity of variance. We already determined that our data are normal. Both groups are normal. We also determined that our assumption of sample size has been met also. Let's look at our test of homogeneity of variance. The very last column in this table shows a significance value of 0.433. We're going to base it on our mean. So since this is greater than the alpha level of 0.05, this tells us that there is no statistically significant difference between the variances in the score variable from the math as usual group compared with the score variable from the ZMath group. So we can conclude that the criteria of the homogeneity of variance has been satisfied, and we can also determine that all of our assumptions have been satisfied. Okay, so going back to these mean scores, so we noticed that ZMath group is higher than our math as usual group. We can also see this graphically. So math as usual group, here's our ZMath group, and so on the basis of these means, we may initially conclude that the school should just adopt the ZMath system, since this group scored higher than the math as usual group. But in statistics, the world is not so simple. So statisticians recognize and actively acknowledge that we do not live in a perfect world, no matter how hard we try to conduct quality investigations. The scientific process can be a messy proposition littered with multiple confounding variables that we just cannot control or account for. So in our simple example, judging by the mean test scores of the two groups, it looks like the ZMath group outperformed the math as usual group. And this may in fact turn out to be the case. But other factors may have contributed to the differences observed between the mean scores of these two groups. For example, maybe the random distribution process unexpectedly routed more math-smart students to the ZMath group. Maybe the class clown was routed to the math as usual group and created amusing distractions during the lessons or the test. Maybe the members of the math as usual group held slumber parties where the ZMath students were not invited and there was very little slumber. This lack of sleep may have adversely affected their concentration levels. Or maybe the ZMath group developed a sense of rivalry which motivated them to work harder to try to outperform the other groups. Any number of these things that we do not know about may have been going on over the course of this study. So, the key question in this case is, how certain can we be that the 5.2 difference that we detected between the groups, the group means, is actually due to the superiority of the intervention ZMath and not due to chance alone? In other words, we want a number that will tell us how likely we would detect this result. So this number is known as the significance level, represented by the letter P. And so here's how the significance p-value works. Let's look at the last column of our ANOVA table. and the significance score is 0.015. This is our p-value. This tells us that we would expect to see the 5.2 point difference in the group scores about 1.5% of the time if it were occurring by random chance alone. In other words, based on the data gathered, if ZMath in fact had a null effect, had no effect at all, we would see the ZMath group outperform the Math as Usual group by 5 points about 1.5% of the time. So, basically, we can say that our ZMath group does have their mean scores are statistically significantly different from our Math as Usual group.